Welcome to Eureka Math. We are in Module 2. This is lesson number 1 of Module 2. And our objective today is to multiply multi-digit whole numbers. So that could be something like 32 or 76 or multi-digit whole numbers and multiples of 10, right? Using place value patterns, we've been using that place value chart, and the distributive property and the associative property. So let's talk about that a little bit. Associative property, I'm going to talk about that one first. The associative property means that if I have a 6 times a 4 times a 3 times a 2, that I can rewrite that problem in any order that I want, okay? As long as all the numbers stay the same, okay? Associative property means that in multiplication and addition 2, right? 6 plus 4 is the same as saying 4 plus 6, or 6 times 4 is the same as saying 4 times 6, right? Associative property says that I can reorder those numbers in any way that I want. Okay, that's what the associative property is. Multiplication and addition, I can put those numbers in any order I want. Subtraction doesn't work that way, division doesn't work that way, but multiplication and addition do. Okay, the distributive property says that if I have numbers inside of parentheses, I can move them around as well. So if I wanted to move this 2 over here, or sorry, this 3 over 2 over, 2 over here, and this 4, this 4 over there, oh my goodness, that is a 2. Sorry, I'm writing too fast. That I can. Distributive property means that I can move things in and around parentheses as well, as long as what I'm doing is the same, right? Multiplication. Okay. So distributive and associative properties. That's what those are. Those are rules in math that tell us how we can move numbers around in an equation. So let's start with the problem set, lesson 1. And please write your name on the paper. Okay, fill in the blanks using your knowledge of place, value, units, and basic facts. Okay, so we're using unit form here. So 22 times 20. Well, we could write that as 23 times 1 times 2 times 10, right? I've basically just expanded this. So this is expanded form. 23 ones is the same as 23 times 1. And 2 tens is the same as 2 times 10. Agreed? I hope so. So what that means is that I can easily multiply this, right? And my answer is going to come out in 10. So 23 times 1 is 23. And 2 times 10 is 20. So that's how they got there, right? But I can also keep this like this, 23 times 2, right? I could just put those in the parentheses and put the 10 outside the parentheses, right? So 23 times 2 is 46. And then if I multiply that by tens, that would be 46 tens. And 46 tens is just 46 times 10. Which equals 460. And you know that because we've been multiplying by tens for weeks now, okay? So a little bit of unit form, a little bit of expanded form, a little bit of standard form, and here we're moving numbers around so that we can better understand where we're going, okay? So 23 tens, they want us to think 23 tens, so we're going to change this into 23 times 10. And then here we're going to change this to 2 times 10. And I'm going to rearrange these numbers, 23 times 2 times 10 times 10. Okay, So now I've got 23 times 2 times 10 times 10. So my answer is not going to be in tens anymore. It's going to be in hundreds because 10 times 10 is 100. So now I've got 46, 23 times 2 is 46 hundreds. See that? Because I moved those tens over. So now I've got 23 times 2 is 46, and then hundreds is 2 more zeros. Now I've got my answer, 4,600. Okay? All right, let's try another one. 41 times 4. So they're saying that this is like 41 times 1, and this is also ones, which would be 4 times 1, okay, equals 164. Well, 164 what? So we've got 41 times 4, and then we move both of the ones into the same spot. So 1 times 1 equals 1. So that's 164 ones. Okay? And 164 ones is just 164, just like that. Next one. Are you following along here with this distributive property and this associative property? So 41 tens, 41 times 10, and 4 hundreds, 4 times 100, equals 164. So they did this, 41 times 4. They moved that 4 over here, and then they're moving the 10 over there, so they've got 10 times 100. Well, 10 times 100 is, so 41 times 4 is 164, because we just had that over here. But 10 times 100 makes 1,000, so we're going to say thousands. And now we've got 164 thousands, right? You see that? So we moved all those zeros over onto that side. Next one. Here we've got, let's see, 331 times 10, right? 331 tens times 3 times 100, right, equals 993, because 3 times 1 is 3, 3 times 3 is 9, 3 times 3 is 9. But now I'm going to use my distributive property to figure out what that number's, what that word's going to be right there. So I'm going to take this 3, 3, 1, and I'm going to move the 3 over to that side. Okay? And then the 10 and the 100 are going on that side. So if 10 times 100 is 3 zeros, so that's 1,000. And now I know that my answer is 993 thousands. Next one. That's easy. 500s times 600s, right? 5 times 100 times 6 times 100 is 30, but then 100 times 100 that's 4 zeros. So 4 zeros would be 10,000, 10 thousands. Okay, so I've got 30 and 1, 2, 3, 4. Careful there. These 4 go from 1, 2, 3, 4, and then the 30 is the 5 times the 6. Okay. All right, distributive property, associative property. This is new. Pay attention. I don't think you did that in 4th grade. You might have. Number 2, determine if these equations are true or false. Remember today we talked about reading directions carefully and taking our time. So defend your answer using your knowledge of place value and the commutative, associative, and or distributive properties. Okay. So 6/10, right? 6/10 would be 60 equals 2/10 times 3/10. Uh-oh. Does that look right to you? Let's try and work it out. I think that this is going to be false. And let me show you why. Let's try it. So if I had 2 times 10 and I had 3 times 10 and I moved those around to say 2 times 3 and then 10 times 10, here I'm going to get 6 times 100, right? Because 2 times 3 is 6, and 10 times 10 is 100. And 6 times 100 would be 600. But they said it was only 6/10s, right? 6/10s is not enough. It would have to be 60/10s or 600s. Okay, so that is false. Next one. 44 times 20 times 10 equals 440 times 2. Okay, let's see if we can get there. This would be 880, right? 2 times 44 is 88, and then a 0 is 80. So what would we have on this side? 44 times 1, because it's 44 ones, times 2 times 10 times 10 times 1, or 1 times 10, right? And that would make 44, and I can move that 2 over there and the 1 over there. And then on this side, I'm going to put the 1 and the 10 and the 10. 1, 10, 10. Okay, so here I'm going to have 88 times 1 is 88. And then 1 times 10 is 10, times 10 is 100. And 88 times 100 would be 88, right? 8,800. But on this side we said 8,800, so this is also false. Okay. Next one. You have to show your work here. 86 ones times 90 hundreds, which would be 90 times 100. Well, here's what I'd like to do. I'd like to change this to 86 times 1. And then I'd like to change this to 9 times 10 times 100. See how I just did that right there? Okay. And that's going to give me, I can multiply this now, 86 times 9. And then on the other side, I would have the 1 and the 10 and the 100. 1, 10, 100. And this would give me, let's see, 86 times 9. 54, 5, 72, 77. Okay. And here is 1 times 10 is 10, times 100 equals 1,000, which would give us 774,000. Okay, that's this side. I don't have enough space today, do I? And 86 ones times 900 tens. Well, that's the same, isn't it? No, it isn't. Yes, it is. Wait a minute. Let's see. Let me change colors. 86 times 1, right, so that's the same, times 900 times 10. Well, I'm going to distribute this one too. I'm going to call that 9 times 100 times 10. And look at that, 9 times 100 times 10. It's the same, it's true. Good, we're going to get the same answer there, 774,000. Okay, next one. Go back to blue. Or maybe I'll switch to purple. Okay. 64 times 8 times 100 equals 640 times 8 times 10. Okay. So, let's see. Let's just compare the sides. 64 times 8, and this I could go 10 times 10. And this side, I'm going to call that 64 times 10 times 8 times 10. So if I look at my numbers here, on the left I have 64, on the right I have 64. On the left I have 8, on the right I have 8. On the left I have 10, on the right I have 10. On the left I have 10, on the right I have 10. Those numbers are equal. This is true. I didn't even need to solve it. Next one, I think I'm going to do that same thing. 57 times 2 times 10 times 10 times 10. So that's problem number 1. If I can split that into that same problem, then I know that they're equal. 57 would be 57 times 10, and that would be still times 2, and this would be times 10. So on this side I have 57 and 57, 2 and 2, 10 and 10, 10 and 10. But I'm left over this one. I have nowhere for that one to go. So this one is false. Number 3, find the products. Okay, this is just some multiplication practice. 7 times 9, 63. 7 times 90, 63 times is the same as 63 times 10, which is 630. 70 times 9 is the same as 7 times 10 times 9 times 10, which would be 63. 7 times 9 is 63 times 100, okay? 70 times 900 would be 7 times 9 times 10 times 100, which would be 63,000. So, if you know your math facts, right, this isn't that hard. So let's try. 45 times 3. Well, let's just multiply. 3 times 5 is 15. Carry the 1s, 12 is 13. 135. All right. So here we would have 45 times 3 times 10. So this we already know is 135 times 10, which would equal, 1,350. Now, we already know 45 times 3 is 135, so let's split this out. 45, this is times 10, and then this would be 3 times 10. Okay, so 45 times 3 is, I'm just going to put this and this here, 135, and 10 times 10 is 100. And my new answer is 13500, 13,500, and 45 times 10 times 3 times 100. Okay, if I wanted to say 10 times 10, I could. And I'm going to redistribute that, 45 times 3 times 10 times 100. Okay. That's 135 times 1,000, which equals 135, 1, 2, 3. Okay. One more time. Let's keep going. Is this the last page? Okay, good. No, wait. Oh, it keeps going. It's a long lesson. All right. 40 times 5. Well, we can already break that apart. Let's just go ahead. 4 times 10 times 5 is, 4 times 5 is 20 times 10 equals 200, right? Okay, so now we've got 4 times 10, I broke that out, times 5 times 10. And I'm going to redistribute 4 times 5 and 10 times 10, which gives me 20 times 100, which equals 2000. Next one, I need to start writing smaller here. 4 times 10 times 5 times 100, right? And I can redistribute that. 4 times 5 times 10 times 100 equals 20 times 1000, which equals 20,000. Okay, now I've got 4 times 100 times 5 times 1,000, which equals 4 times 5 times 100 times 1,000, okay, which is 20 on that side. And here I've got 1, 2, 3, 4, 5 zeros. Which is going to give me 1, 2, 3, 4, 5, 2 million. 1, 2, 3, 4, 5, 6. Good. Next one. Okay, 718 times 2. So I'm just going to multiply it the old-fashioned way. 2 times 8 is 16. Carry the 1. 2 times 1 is 2. Plus 1 is 3. 2 times 7 is 14. There we go. 1,436. Now I've got this big number, and I'm just going to call this 718 times 10 times 2 times 10. Okay? And I already know that 718 times 2 equals 1,436, and then 10 times 10 equals 100, and my answer is 143,600. Okay, next one. Oh, I'm going to change colors just so you don't get mixed up here. I'm getting a little squished in with my writing. Okay, so 718 times 10 times 2 times 100, and 718 times 2 times 10 times 100, right? 10 times 100. That is 1,436 times 1,000, which is 1,436,000. Okay, 1,436,000. And finally, I'll switch colors one more time. Let's see, this would be 718 times 100 times 2 times 1,000. And now I've got 718 times 2 times 100 times 1,000, which is giving me 1,436 times 1,000,000, 100,000. And my new answer is 1,436,000,000, which gives me, careful with your, 143,600,000. Okay, Look at those big numbers you guys are dividing. Awesome. Or multiplying. Nice job. And your lesson 1 problem set number 4. This is definitely the last page. This is a long one. Ripley told his mom that multiplying whole numbers by multiples of 10 was easy because you just count zeros in the factors and put them in the product. He used these 2 examples to explain his strategy. So here's what he did. He said 7 times 6 is 42, and then he counted 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that one worked, didn't it? Okay. This one, what's 8 times 7 is 56. And then 1, 2, 3, 4. 1, 2, 3, 4. And that worked as well, didn't it? Okay. Ripley's mom said his strategy will not always work. Why not? Let's give an example. Okay, I'm going to give you the example of 400 times 500. Why would that not work in the same way? Right? Because 3 zeros plus 2 zeros equals 5 zeros. 2 zeros plus 2 zeros equals 4 zeros. Well, let's try this one. 4 times 5 times 100 times 100, right? So I still see those 4 zeros there, would equal, right, 10,000 on that side, so that's still 4 zeros. But over here, 4 times 5 is 20. So we have to remember that 0 there. So we're going to get 20 is the answer times 1, 2, 3, 4. 1, 2, 3, 4. Well, that gives us 200,000. But we started with 2 and 2, right? Which should equal 4. But over here we have 5 zeros, right? So you do have to be careful. You do have to be careful, okay? Number 5, the Canadian side of Niagara Falls has a flow rate of 600,000 gallons per second. So that's the catarata between Canada and the United States. It's in the state of New York, and then it goes up to Canada. And flow rate is how fast the water goes through, okay? So 600,000 gallons of water go past Niagara Falls per second. How many gallons of water flow over the falls in 1 minute? Okay, so we have 600,000 gallons per second. If we want to figure out a minute, we have to multiply, right? What are we going to multiply? We're going to multiply times how many seconds are in a minute. There are 60 seconds in 1 minute. So we're going to have to multiply by 60. So 6, 0, 0, 0, 0, 0 times 60, okay? And that's going to give us our answer in gallons. So let's solve this with our distributive property. I want to call this 6 times 100,000, and this 6 times 10. And I'm going to move the 6 over here, and the 100,000 over there. I kind of feel like using powers of 10, right? Don't you guys? Ooh, that's a lot. Okay, so my answer is 6 times 6 is 36. And 100,000 times 10 is 1 million. So my answer is 36 million gallons. That is a lot of water in 1 minute. Wow. Number 6, tickets to the baseball game are $20 for an adult and $15 for a student. A school buys tickets for 45 adults, okay, 45 adults at $20, and 600 students at $15. That's a big school. That's like twice the size of our school. Okay, so first of all, how much money will the school spend on tickets? 45 adults times $20, right, equals how much they spent on adults. And 600 times 15 is going to be how much they spent, on the kids. Okay, so let's use the distributive property here. 45 times 20. I can rewrite that as 45 times 2 times 10, right? I just split the 20. And that's easy. 45 times 2 is 90, plus 10 is 900, right? Or multiplied by 10. So $900 for the adults. Now, over here, I'm going to multiply this. I'm going to split this out. 6 times 100 times 15. And 6 times 15, if you can't figure that out in your head, is 90, right? And 90 times 100 equals 9,000. Okay, is that right? Yes. 15 times 9. Yep, okay. So, my brain is jumping ahead of my pen. Now I have to add those two together to get my answer. Okay, how much money will the school spend on tickets? $9,900.00. All right, multiplying by tens. I think what we could really do here, if we felt like it, is we could use our powers of 10, and we could call that 10 to the 5th and 10 to the 1, and I just think that makes it all just so much smaller, so much easier. But another day. Wonderful. If you have any questions, please let me know in class. Please take your time and read the directions as always. Have a great day.